For this video, we're looking at derivatives of exponential functions. So if you start with the function y equals e to the x and you look at it graphically, you'll notice some things about the slope. As you approach negative infinity, the slope is actually approaching 0 because there's an asymptote at y equals 0. So it's getting closer and closer and closer. So the slope is headed towards 0. As you approach positive infinity, the slope is getting steeper and steeper and steeper. So this is the one function where you'll notice the y values match the slope values. So as you go to the left, the graph is approaching an asymptote of 0, so it's approaching y equals 0. Well, the slope is flattening out, so the slope is approaching a 0 as well. As you go to the right, the y values are getting higher and higher and higher, and the slope is also getting steeper and steeper and steeper. So we know that y prime is the same exact function, e to the x. So for our derivative rule with the chain rule, we would know that if we have e to the u, and we're taking the derivative of it, it's going to be e to the u times u prime. Now, something that most people do when they're actually taking the derivatives of exponential functions, they will take this u prime and move it to the front, so it looks like it's the coefficient of e to the u. So a basic example is if you have f of x equals e to the 5x. Well, this 5x is in parentheses, whether you see them or not, and so I would say u equals 5x. That means that my u prime, the derivative of my inside function, will be 5. The rule is that f prime of x will equal e to the u, so e to the 5x times u prime times 5. And you can see that this is a little bit awkward. So generally we write f prime of x equals 5e to the 5x, and that is the derivative. For this problem, if you have an e to the negative 2x, my u equals negative 2x. So my u prime equals negative 2. So this function, the derivative of this function will be f prime of x equals e to the u, e to the negative 2x times a negative 2, and I'll put it up front. Slightly more complicated, you have e to the 2x minus 6. So u equals 2x minus 6. My u prime for this just equals 2, the derivative of 2x minus 6. So it looks like it might be more complicated, but honestly it's just as easy. The derivative of this constant is 0. So f prime of x will equal, and I'm going to put my u prime up front, so 2e to the u, 2x minus 6, and that problem is finished. If you have something that's not linear, then it doesn't change your method. U would equal x squared minus 8x. So my u prime will equal 2x minus 8, the derivative of my u. So for this function, f prime of x equals 2x minus 8, it needs to be in parentheses, times e to the u, x squared minus 8x. And it's in parentheses. If you leave the parentheses off, it'll look like you're just multiplying the e to the x squared minus 8x times the negative 8. So make sure that it's in the parentheses. This one's slightly more complicated because you have an inside function inside of your inside function. So for this, it is e to the u. So my u, my official u, would be 3 times the cube root of x squared plus 2. But you can see that I have another inside function. So what I'm going to do is something with the PTA rule. It's P, T, A. And we're going to multiply the derivative of the power times the derivative of the transcendental function times the derivative of the argument. So I have to deal with the power, the transcendental, and the argument in some kind of order. And all that really reminds you is that you're going to have three things going on. I'm going to have my e to the u times my u prime, which is the derivative of this, times another u prime, the derivative of the argument, the x squared plus 2. So I'll just take it in pieces. I'm going to rewrite this u. This is 3 x squared plus 2 to the 1/3. And this is still my u equals. So now when I do my u prime, I'm going to deal with my power here. So u prime equals 1/3 times 3 is 1, x squared plus 2, I have to subtract 1, so to the negative 2/3, times the derivative of my argument, the inside, which is a 2x. So if I rewrite my u prime, I have a 2x in the numerator. The 1 is also in the numerator, but it's not affecting anything. The x squared plus 2 is in the denominator because of my negative exponent. It's to the second power, and I'm taking the cube root. So this entire thing is my u prime. And you can see I've dealt with my power, I've dealt with my argument, and then we have our derivative of the transcendental function. I'm going to say f prime of x is equal to e to the u times u prime. So it's this entire function multiplied by this function, which will put my e to the u in the numerator. So I'm going to say it's 2x e to the 3 times the cube root of x squared plus 2 over the cube root of x squared plus 2 squared. And that is my derivative. Now, to work some other kinds of problems when you have to actually have a derivative of an exponent, there are a couple of different things they could ask you to do. So let's just say they asked for the equation of the line tangent at x equals 3. So we're going to be tangent to this function f of x equals e to the 5x minus 6x. And I need an equation of a tangent line. So I know to write the equation of a tangent line, I need a slope and I need a point. They gave me the x value, so I know x equals 3. If I want to find the y value, I'm very simply going to evaluate my function f of x at x equals 3. So f of 3 equals e to the 5 times 3 minus 6 times 3. So my f of 3 will equal e to the 15 minus 18. And that's my y value. To get my slope, I know that the slope of a tangent line is the derivative, and I'm going to evaluate it at x equals 3. So I need to find f prime of x. So you evaluate derivatives, you take derivatives term by term. So I have e to the u, e to the 5x. My u equals 5x. So my u prime will equal 5. So the derivative of e to the u is e to the u times u prime. So I'm going to say that this is 5, putting my u prime up front, e to the 5x. My next term is going to be a negative, and the derivative of 6x is 6. So this is my derivative. It gives me the equation to find the slope at any x value. So my next step is to figure out what is f prime of 3. And that will give me the slope of the tangent line when x equals 3. So I evaluate at 3, and this is 5e to the 15th minus 6, and that is the slope. Minus 6 down here. Be careful with your exponents. So the equation of my line will be y equals, I'll put my slope first, and because it has two terms, it has to be in parentheses. And then this point has been shifted from the origin 3 to the right, and e to the 15th minus 18 up. So I'm going to say x minus 3 plus e to the 15th minus 18. You have to have parentheses around this because I'm taking the entire slope and multiplying it by x minus 3. I don't need parentheses here because I'm just adding it in. If I was subtracting something, I would have a minus and then I would have parentheses around it. But that is the equation of your tangent line. They could also ask you just to evaluate a limit. And if you see something like this, you should recognize the slope formula. So we have y2 minus y1, and then down here we have our h. X is approaching h, and you've seen this before. This could be x plus h minus x, and you'll see that that would give you an h. So you want to check and make sure this really is the slope formula. So if you had 2 points, one of them would start x, and the second x plus h. So if I plug x in, the x is going to match with the e to the 2x squared plus 6. If I plug x plus h in, it's e to the 2x plus h squared plus 6. And you can see that this matches exactly. So we are finding the slope, and you'll notice that the limit is here. The limit as x approaches h, so our 2 points are being pushed closer and closer and closer together. So what that means is that this is the slope of the tangent line rather than the slope of the secant line. And hopefully you can look at this equation and just recognize it for that, but if not, break it into the pieces. And we know that the slope of the tangent line is the derivative. So this represents the derivative, and it's the derivative of our function with x's. So of e to the 2x squared plus 6. So we actually want to figure out what is the derivative. You don't have to work on the limit problem if you can recognize what it is. So I need the derivative of e to the 2x squared plus 6, and this plus 6 should be up in the exponent. Shame on me. So it's e to the 2x squared. It should look like this, with the 6 up there. So now I know, okay, I'm taking the derivative of this. The derivative of e to the u is e to the u times u prime. So for this problem, my u equals 2x squared plus 6. So my u prime equals 4x. And the answer to this limit question would be 4x times e to the 2x squared plus 6. The derivative of e to the 2x squared plus 6.